Hi guys, welcome to this video where I'll be going through Madas practice paper E, which is made for AS Pure Maths. So let's have a look at the first question. So in this question, we've been given two functions, y equals x plus 1 whole squared and y equals 4x plus 9. And for the first part, we just need to find out the coordinates of the points of intersection between the two curves. And that's pretty simple. Okay, so you just have to solve the two equations simultaneously. And for that, I'm going to put them equal to one another. So it'll be x plus 1 whole squared, which is equal to 4x plus 9. And that further simplifies to x squared plus 1 plus 2x equals 4x plus 9. Now, just rearranging it, and that gives me something like this. And now I'm just going to factorize it out into x minus 4 and x plus 2. So that gives me x equals 4 and minus 2. Now I can just use one of the two equations given to me. I'll choose the y equals x plus 1 whole squared, for which y equals 25 when x equals 4. And when x equals minus 2, y turns out to be 1. So that's that, basically. My 2 points of intersection for the two curves or two functions is 4, 25 and minus 2, 1. Now, in this part B, it says, hence solve the inequality x plus 1 whole squared greater than or equal to 4x plus 9. Now, for this, I have to be careful because there is a greater than equal to sign given to me. So I'm just going to have to highlight that region, which is just above the section of the line. Okay, so the curve which lies above the line will be my region. So for this, I've got the two corresponding values of x. One is 4 and the other one is minus 2, and I found them out in my previous part. So quite simply, it will be x less than equal to minus 2, or x will be greater than equal to 4. Okay, those are my values of x. Okay, so now for the next question, number 2, I've been given a circle with the center at the origin, and the radius is r. And this circle fits wholly inside the other circle. I'm going to just make this into a complete square so that I can get my center and the radius. All right, so that leaves me with x minus 5 whole squared plus y minus 12 whole squared equals 400. And that gives me center as 512 and radius as 20. So I'm just going to draw this out, okay? It's just a rough sketch. So I've got my big circle, okay, with this radius 20, and the other circle is going to fit right inside it. Okay, so just gonna roughly sketch that out in another color, and like so. And the center of the circle is given to me, which is the origin, and the radius is r. Okay, so I need to determine the range of possible values for r. So O to D is basically 20, okay, and O to C is going to be simply 5 squared plus 12 squared, which gives me 13. Now, I need to work out the possible values of r, so I'm going to label another point E. So O to E is equal to r. And I know that r has to be less than equal to 20 as it fits inside the bigger circle. So I can simply say that 13 plus r, okay, so it's the OC plus the r, okay, which is O to E, is less than 20, and therefore r is less than 7. For question number 3, I am given a function fx, and we need to show by factor theorem that x minus 2 is a factor of fx. And for this, I need to express it in a linear and a quadratic factor. So that's really simple. I'm just going to put in x as 2 into my fx function, which gives me 2 cubed minus 9 times 2 squared plus 13 times minus 2 plus 2, which gives me 8 minus 36 plus 26 plus 2, which is equal to 0. So therefore, x minus 2 is a factor of fx. So in order to find out the quadratic factor, I'm going to do long division. That's the method I prefer. And I'm just going to set up my bus stop method, well, long division method. So x squared gives me x cubed minus 2x squared. Taking them away will give me minus 7x squared plus 13x plus 2. So I'm just going to finish this off as you guys could probably easily follow. And it'll give me minus x plus 2. So here I've got my quadratic factor, which is x squared minus 7x minus 1. So you can just rewrite this fx like so. And that's that. Okay, so now for part B, I've basically got a sketch. Now for part B, it asks us to sketch the graph of gx, indicating clearly the coordinates of any points where the graph meets the coordinate axes. So when x equals 0, g of 0 is simply equal to 0. Okay. Now, for when y equals 0, we are going to have three values of x equals 0, 2, and 4. And remember, this is a cubic function, a positive cubic graph, so it will have a normal shape, nothing unusual over there, and it will look something like so. So we've got something like this, and you've got the coordinate axis 0, 0, 2, 0, and 4, 0. All right, so that's it for part B. Now, for part C, we have to determine the exact coordinates, where appropriate, of the points of intersection between fx and gx. So I'm going to solve this simultaneously, and by doing so, I'm going to get all my values of x. So I've got x cubed minus 9x squared, or rather, I'm going to just write down my factorized form. So that's that, and this will be equal to the g of x, which is this. Now, over here, x minus 2 is common, and we notice that it was a factor of fx as well as gx, so x equals 2. Okay, so it is a solution, and therefore it would be a point of intersection, so we can just say it will be 2, 0. Okay, now for the rest of it, so I'm just going to put it out here. For the rest of this, you're going to have x squared minus 7x minus 1, which is going to be equal to x brackets x minus 4. So expanding the right-hand side will give me x squared minus 4x, and cancelling the x squares will give me minus 3x, or 3x is equal to minus 1, and therefore x is equal to minus 1 over 3. And for this, I need my y value, and for this, I'm just going to use one of the equations to give me y as 91, or minus 91 over 27. So that's one of my points of intersection, and the other one is 2, 0. So there I have it, my 2 points of intersection. Now for question number 4, we are asked to sketch the graph of y equals 2 root x in its largest real domain. What that means is you can't have negative values of x. Okay, so starting with x being positive, we can plot the graph and the values of y will gradually increase. Okay, so it will be a curve and it will look something like this. All right, so that's pretty much it for the first part. Okay. For part B, we have to describe a single geometric transformation which maps the graph of y equals 2 root x onto 3 root 2x. So we have to think over here backwards. Okay, so what do we need to change 3 root 2x by to get 2 root x? Okay, so let's put a question mark there. Now, 3 root 2x can be written as 3 root 2 and then root x. Okay, so I'm just breaking this down so that I can digest it into little chunks. And now I can just divide and times, okay, by 2 because I need to introduce a 2 outside the surd. So that's my original function. And 3 root 2 over 2 is therefore my scale factor. So this tells me that there is an enlargement. Okay, so an enlargement along the y-axis because the factor is outside the brackets by a scale factor of 3 root 2 over 2. Okay, and for the third part now, we have to describe another single geometric transformation which does the same job. Okay, so maps 2 root x onto 3 root 2x. So again, let's think backwards over here. And I can write 3 root 2x into 2 times 3 over 2 root 2x. Okay, just introducing a 2 again. And popping it back into my surd will give me 2 times root of 9 over 4 times by 2x. Okay, so this simplifies a little bit into 2 times root of 9 over 2x. And there you have it. I have the 2 outside my surd and a 9 over 2 inside my surd. So therefore the enlargement over here will be along the x-axis, but remember you flip, okay, the factor. So enlargement along the x-axis by a scale factor of 2 over 9. All right, so that's that. So for question number 5, we have to solve the following trig equation. So sine 3 theta plus 72 equals cos 48. And for this, we need to have the same functions on either sides. And sine 90 minus theta equals cos theta. So I'm going to use this in my equation and perhaps write down sine 90 minus 48, okay, which is going to be equal to cos 48. All right, so that simplifies to sine 42. And I can now equate this to the sine 3 theta plus 72 and take sine inverse of both sides, which leaves me with 3 theta plus 72 equals 42 plus or minus 360 degrees n, where n is simply 0, 1, 2, and so on. So that's my main primary value, but I have to think about the cast diagram as well. So according to the cast diagram, sine is positive in the first quadrant and the second quadrant, which is both 42 degrees. So I need to work out that 180 minus 42, which stands for 138 degrees. So therefore, 3 theta plus 72 is also equal to 138 plus and minus 360 degrees n. So let's talk about the first one and rearrange to make 3 theta or theta the subject. So it will be minus 30 plus or minus 360 n, dividing both the sides by 3 will give me something like this. And this will further give me 110 degrees if I was to take 10 away from 120. Similarly, for the second part, 3 theta is equal to 66 degrees plus or minus 360 degrees n. And that further simplifies to 22 plus or minus 360 degrees n. And again, that will give me 2 values over here for n equals 0 and 1. Okay, so here I've got 3 values of theta. One is 22 and 142, and the other one is 110 degrees. Now in question number 6, we are given 3 well-defined functions, and we need to use binomial. So let's start with fx as 1 minus 2x to the power of 6, which can be written as 1 plus c, or 6c1, minus 2x plus c62 minus 2x whole squared plus c63 minus 2x cubed, which further simplifies to 1 minus 12x plus 60x squared minus 160x cubed, and so on. Similarly, for the next function, we are given gx as 2 plus x to the power of 7, and that expands to 2 to the power of 7 plus 7c1 2 to the power of 6x plus 7c2 2 to the power of 5x squared, and so on and so forth with the fourth term. Now, that further simplifies to 128 plus 448x plus 672x squared, followed by 560x cubed. So that's part A done. Now for part B, it says, hence determine the coefficient of x squared. So of fx times gx. Okay, so we need to multiply these two together, and just be careful only to expand or compare the x squared terms. So I'm going to just put these two expansions together in one place and expand it carefully, just only looking at the x squared terms. So when I multiply out, I just have to look at the first number, so 1, and that would have to multiply with 672x squared. All right, so that will give me 672x squared. Followed by, I have to think about the minus 12x multiplied with 448x, which will give me minus 5,376x squared. And finally, I've got the 60x squared, which needs to be multiplied with 128. So that will give me 7,680x squared. So those are all my x squared terms, and I just need to simplify this to 2,976, and that will be my answer. So now for question number 7, we are given a graph with 2 equations, and we need to determine the coordinates of A and B. So for this, I just need to simplify, or solve them simultaneously. And that will be 4 bracket x minus 2 squared equals 2x squared minus 9x plus 16. Expanding the left-hand side will give me 4x squared plus 4 minus 4x equals 2x squared minus 9x plus 16. And now multiplying out will look something like this, where I will be able to just cancel the 16s together. All right, so I'm left with 2x squared minus 7x equals 0, for which I'm going to factorize into x, and 2x minus 7 equals 0, and x equals 0, and x equals 7 over 2. So for this, I'm going to get the corresponding y values as 16 and 9 by plugging into one of the equations given to me already. So that's part A done. Now, for the next part, we have to find the exact area of the finite region defined by the two curves. So let's just put down the points relevant to us. Now, both the curves are intersecting at the same point. So all I have to do is take the area of one curve and take it away from the area of the other curve, which means that I simply have to look at the first curve. Let's highlight this in pink. So that's my 2x squared minus 9x plus 16 curve. And the area underneath that can be found using integration. And I will have to take it away from the area under the green curve. Okay, so that will be something of this sort. So you probably know what I'm trying to say here. Okay, now take the areas away, or take the equations away from one another, because they do intersect at the same point. So we can reduce our work over here rather than individually integrating. We can just simplify the expression and get a singular expression and then integrate. So 2x squared, or rather minus 2x squared plus 7x, can now be integrated between 0 to 7 over 2. Okay, so let's put our expression of the integral together and integrate as minus 2 over 3x cubed. So I'm just adding 1 to the power and dividing by it. And 7 over 2x squared. So now I'm going to put in the limits, and I'll get something like minus 343 over 12 plus 343 over 8. So that simplifies to 343 over 24, and that will be my answer. Now, in question number 8, we're given a trapezium OABC, and the position vectors of A and C are given to us as well. And I'm going to write down OA and OC first in terms of the column vectors. And they are just simply 12, 4, and OC is 18 and minus 21. Now from here, the first part says find an expression in terms of I and j for the position vector of D. So for this, I just need to write down OD. Okay, OD can be written simply as one of the many different pathways. So OD is OA, for example, plus AD. Now, we already know what OA is, all right, but we don't know what AD is. So let's write down OA as 12, 4, and AD is simply 1/3 of AC. Okay, that's the ratio given to us already. So AC is written as perhaps AO plus OC, which can be simplified into minus 12 minus 4, because we are going the opposite direction, plus 18 minus 21, which then further simplifies to a 6i minus 25j. Okay, so therefore OD is going to be 12, 4 plus 1/3 of that vector over there. And that gives me a 28, or rather, not 28, 14i, and minus 25 over 3j. Okay, so that's OD done. Now, for the second part, we need to show that ODB are collinear, which means that they lie on the same line, okay? They lie on the same line, and therefore they should be in the same vector form. So if I need to work out the ratio of OD to DB, I can think of OD can be written in terms of OB. But I also need to find out what DB is. Okay, so because that's one of the ratios I need. So DB is to be found as well. So let's go ahead and find out what DB is first. So DB can be written as DC plus C to B. So let's just join the D to B together. And now for D to C, I know it is 2/3 of A to C, okay? And C to B is just twice of, well, OA, which is already given to me as 12 and 4, so twice of 12 and 4 there. Now, I already know what AC is, okay, so 6 and minus 25. And that becomes 24 over 8, which then simplifies to 28I minus 26 over 3j. So that's my dB done, okay? Now, on the other hand, if I look at OD, OD was written as 14I minus 13 over 3j. Okay, now that is exactly the same, in the same vector form, but half of dB. Okay, so dB is twice of OD, which means that OD can be written in the same form as OB or DB, and the ratio is just 1 to 2. Now, in question number 9, we have to solve two equations. One is indicial, and the other one looks like a log equation to 3 significant figures where appropriate. So for the first equation, I'm going to just put the 4's together on one side. So 4 over 4 to the power of x. And on the other side, the 3's together, like so. Now I'm going to use indices to just take away the powers. So 1 minus x plus 2 inside the brackets. And then I'm going to just expand the brackets on the right-hand side. And I'm just going to end up getting, well, just minus 1 minus x. Okay, and from here I'm going to use log. So logging both sides will bring the powers to the front. So 1 minus x log of 4 equals minus 1 minus x log of 3. From here, I'm just simply going to expand the brackets. So log 4 minus x log 4 equals minus 1, or minus log 3 minus x log 3. So now I'm just going to put my logs together and my x's on one side. So log 4 plus log 3 is equal to log of, well, x log 4 minus x log 3. So from here, just gonna take out the x common and divide by log 4 minus log 3. And that simplifies to 8.64 when you pop it in the calculator. Now, for part B, we're given a log equation. So I'm just gonna jot it down. And now remember that if I have a half in front, I cannot just directly use log rules. So I'm going to bring the half as a power. So that will look something like this, okay? And from here, I can simply get rid of log a, okay? So that leaves me with the brackets, and I just have to simplify this algebraically, okay? So squaring both sides, and now expanding the brackets will give me something like this, and then putting everything on one side will help me further factorize this. So I'm going to be left with 1 plus, or rather x minus 2 root x minus 8 equals 0. Now this is hidden quadratics, as you guys know, and root x is related to x in terms of its square. So I'm going to let root x as y, so that it becomes y squared minus 2y minus 8 equals 0. And I'm just going to factorize this into y minus 4 and y plus 2 equals 0. Y is therefore 4 and minus 2. So therefore root of x for when y equals 4 is simply giving me x equals 16. And now when you put root of x into the main function, it will give you a negative value. Okay, so you have to ignore it, therefore x equals 16 only. Now for question number 10, you're given an equation of the circle and you need to write down the coordinates of the center and the radius. So that's quite simple. That's just 2 comma minus 2, and radius is just the square root of 20. Okay, now we need to sketch the circle, writing down all the coordinate axes, and for this I'm just gonna first work out where the circle crosses the y-axis. Okay, so when x equals 0, it will give me minus 2 squared plus y plus 2 whole squared equals 20, and that just gives me y plus 2 whole squared equals 16. Square rooting both sides will give me plus or minus 4, and y equals therefore minus 2 plus or minus 4, for which therefore y equals either 2 or minus 6. Okay, so those are my two coordinates on the y-axis. So I've got on my x-axis y is 0, so that brings me x minus 2 squared plus y squared, sorry, that should be plus 2 squared over there, so equals 20. So x minus 2 squared equals, again, 16. And from here, I'm just going to do square root, so plus minus 4, and therefore x equals 2 plus or minus 4. So x equals either 6 or minus 2. So I've got all my values of x and y coordinates. I'm going to just go ahead and plot the circle. So if I just draw out a circle, a rough sketch, I'm going to have all my coordinates. So let's draw a circle, and I have my x coordinates as minus 2, 0, and 6, 0. And on the y-axis, I've got a minus 6 and a 0, 2. And so that's the sketch done. Now, for the next part, I have been given a straight line with the equation y equals 2x plus k, and I need to solve it simultaneously to show that the coordinates of the intersection satisfy the following equation. So I'm going to put this equation of the line into the circle's equation. So x minus 2 squared plus 2x plus k plus 2 whole squared equals 20. Now, so that's going to give me x squared plus 4 minus 4x for my first bracket. And then for the second bracket, I'm just going to expand carefully, and it will give me 4x squared plus k squared plus 4, followed by 4xk plus 4k plus 8x equals 20. So from here, I'm just going to simplify this into 5x squared. And I've got my x's together, so 4kx plus 4k, sorry, 4x plus 8 plus 4k plus k squared equals 20. And I'm just going to simplify so I'm going to have 4k plus 4 inside the brackets along with the x, and the rest remains the same. So I've got my quadratic in the form of a, b, and c. So for the next part now, we've got to find the two values of k for which the y equals 2x plus k line is a tangent to the circle. So remember b squared minus 4ac equals 0 here, because the tangent only cuts the circle at one particular point. So you're going to have only one solution. And so I'm going to just set this up in using my previous equation from part C. Okay. And then I'm simply going to expand it carefully. So 16k squared plus 1 plus 2k minus 20 brackets k squared plus 4k minus 12 equals 0. And that will give me minus k squared minus 12k plus 64 equals 0, which further simplifies to k minus 4 and k plus 16, which is equal to 0, and k equals 4 and minus 16. Okay, and that's it.